Focus on this and you'll get it. This is not, a lot of this is review. What we want to look at today, and just let you know kind of what the deal is. I'm going to get the lab tomorrow. If you need some time to, finish up chapter 6 stuff, that's fine. We'll have the lab tomorrow. I want to put an assignment up for chapter 7 so that you can jump right into that. We just can't have any downtime here at the end. We just have enough stuff to do that we got to just be stacking it up a little bit. Hopefully, perhaps, we can have a little time here at the end too. If you have some chapter 6 questions, maybe we can get some of those too. Otherwise, we'll just take them in the lab. What I want to look at today are how we deal with roots other than square roots. Okay, so we're going to just say in general, we'll call these nth roots, where n could be anything. The way we'd write that would be something like, if I want to say the nth root of something, I would say that. That says the nth root of a. Notice that there's a little number that goes up here on the radical sign. Now for a square root, it's a 2. We just don't write it. It's just invisible, but it's there. We call this little number, it's got a name, we call this the index of the radical. It tells us what kind of root we're taking. There are some rules that go with this. Okay, here's what we know about the index. First of all, when we're taking nth roots, one thing that's always easy is, we'll kind of break these up into numbers here. If a equals 0, that's easy. We know that regardless of what the index is, the nth root of 0, where n could be anything, is always what? You suppose?
1.
No?
0.
0, yeah. Because think what that's saying. The nth root of something is saying, what to the n is that number? Well, what number to any power equals 0? 0, yeah. So no matter what kind of root I'm taking, square root of 0 is 0, cube root of 0 is 0, a millionth root of 0 is 0. Okay, so that's an easy one. Now, let's look at some other circumstances here. We got some things to look at. We're taking nth roots. If n is an odd number, 3, 5, 7, 11, 21, etc. So if the index, if we're taking an odd root of a number, that makes life easy. If it's an odd root, that means we always get exactly one real answer. Okay, let's take an example. The cube root of 8 is what? That's just saying what number cubed is 8, right? 2. It's exactly 2. There's only one answer. That's it. What about the cube root of negative 8? Negative 2, right? Now think about that, because negative 2 times negative 2 is what? 4 times another negative 2 gives me negative 8. So yes ma'am.
So the I thing is
Exactly what we're getting at. So if n is an odd number, we can put negative numbers into odd roots and we get answers. I doesn't apply. I only is going to apply if the index is even. If it's odd, a could be anything. So that's really important. We got to add that little note here. If n is odd, then a can be negative. There's no I involved. Okay? That's probably good news. And so those kind are simple to deal with. If n is odd, we're fans of those. Okay? Now let's look at the more complicated case where if n is even. Now we've already done this because a square root is an even root, right? A square root is a second root. Okay, everybody should have all stuff away. You absolutely do not want to miss this. This will cause you problems. So everybody put all your phones and things away. So if n is even, like a square root, or a fourth root, or a sixth root, or a 10th root, or something like that, then we have some issues. Thank you. Where's Lindsay? Oh, shoot. Man, if n is even, we do have to be a little careful. If n is even, then we know that, first of all, if we're looking for real roots, we can't put a negative number in there, can we? Because we're going to get i's, right? So if n is even, then we get some other things we got to worry about. If n is even, then if a is less than 0, right? I should put it that way. If a is less than 0, then we get no real answers. We're going to get i's, right? For example, the square root of -4 gives us i's, doesn't it? Right? That gives us plus or minus 2i. Okay? The same kind of thing is going to happen for other even roots. If I try to take the 8th root, that's an even number. The 8th root of -10 has no reals. Okay, we're going to get i's there. It's a little more complicated, but we won't even bother with them. We know we're going to get imaginary answers, and we don't want those. We're going to focus only on real answers in chapter 7. Okay. So if n is even, first of all, a can't be less than 0. Now, what if a is positive? Well, if a is positive, then we know that we always get 2 real answers. And we have some familiarity with that. We've done this stuff, right? For example, the square root of 9 gives us back plus or minus 3, doesn't it? Right? Okay? So we already kind of are familiar with that stuff. Now, where this comes into play, where this is more useful to us, is when we're solving for variables. Like, for example, what if we had something like x squared equals 9, right? Then we know how to solve that. We get x equals plus or minus the square root of 9, so it equals plus or minus 3, right? The same kind of thing happens when we're dealing with other even roots. What if we had something like x to the 4th equals 16? Okay? Then because that is even, we're going to get x equals plus or minus, exactly, good, the 4th root, the 4th root of 16. Can anybody tell me what the 4th root of 16 is? 2. Yeah, because 2 to the 4th is 16. So my answer is, in this case, is also x equals plus or minus 2. Okay? See how that works? So for evens, you get the plus or minus. For odds, you don't. Okay? But for odds, you can also put in, you can take odd roots of negatives. You just can't for evens, right? Okay, if we had something like, let's say, x to the 10th equals negative 931, do we have to do anything?
No.
No, because we would be taking an even root of a negative number, and that's, we're not going to get any real answers. We're done. We know there are no real answers to that one. Okay? All right. Oops. Okay, so what about this then? We can also do stuff like this. We could say fractional exponents that don't just have numbers in the bottom, have in the denominator, they have numbers in the numerator also. Things that look like a to the m over n. And all that means, think what that means. I could rewrite that using my properties of exponents. A to the m over n, isn't that the same thing as a to the 1 over n to the m? Because what happens if we take a power to a power? What do we do to the exponents? We multiply, right? And isn't 1 over n times m just equal to m over n, right? Because really there's just a 1 on the bottom of that, right, if I want to put it there. Okay, well, think what that's saying then. That's saying a to the 1 over n, that's the same thing. Did I tell you about this? I can't remember if I did. If I didn't, I'm going to do it now. Okay, I'm going to add something here. We can write an nth root like this. We can write that as a fractional exponent, a to the 1 over n, which we also kind of know about because we've done that with square roots a little bit, right? What's the advantage of that? Well, I mean, there's not a huge advantage to that, although it is easier to put that into your calculator than it is to fish around finding the nth root button on your calculator. It's easier. If I want to take like a 12th root of a number, I just take the number to the 1/12th power, and that's a really easy way to do it, quick and easy way to do it. But these are equivalent. Okay, so if we know that, if the nth root of a is the same thing as saying a to the 1 over n, so the index just goes on the bottom of the fraction, then what happens here in this case? Well, I can write a to the 1 over n. That's the same thing as the nth root of a to the m. Okay, this is a really convenient way for us to think about a to the m over n. Okay, for example, if I want to take a number like 9 to the 3/2, all I want to do, I always want to start with the bottom. It seems like maybe we wouldn't want to, but we do. We want to start with the 1/2 part, and we want to think of that as being the square root of 9, because that's what 9 to the 1/2 is, right? The square root of 9 cubed. What is the square root of 9? 3. So that's just 3 cubed, which is what? 27. Right? Okay, you try one. What is 8 to the 2/3? Now, think about that. What does a 1/3 power mean? Cube root, right? So we want to break this up into a cube root of 8 squared. What's the cube root of 8? What cubed is 8? 2. 2 squared is 4. Right? See how that works? Okay. What if I have a negative? Like 32 to the negative 2/5. Don't panic with the negative. What's that mean? We have a negative exponent. Yeah, just goes to the bottom, right? So that's the same thing as saying 1 over 32 to the positive 2/5. Now let's take care of the 32 to the 2/5 part. What's the 5th root of 32, do you suppose? It's an integer. It's a nice answer. Picked a good one for it. 2. Yeah. 2 times 2 is 4, right? 2 squared. Times 2 is 8. Times 2 is 16. Times 2 is 32, right? So that's just going to be 1 over 2 squared. 1/4, right? Once again, if I do 32 to the 2/5, I do the 1/5 part first. 32 to the 1/5 is 2, squared is 4. Okay? All right. So how do we do that on a calculator? Do I have my calculator? Oh, I don't. To show you 2 ways to do this on a calculator. Okay, so if I want to do something like I want to take the, what if I'm taking a root of a number that's not nice and convenient. We can do that too. We're just going to get decimal answers. What if I want to do something like, let's say, the 6th root of 91. Okay, how can I do that on the calculator? A couple ways. If I want to use the nth root feature on the calculator, it's there. There's probably a real quick way to get to it, but I know if you go math, it's right there, number 5. Yeah, there it is. X, it has an X up there instead.
Yeah.
So if I hit 5, look what it gives me. It gives me, oh, hang on.
You just gotta go back and delete the answer.
Yeah, so I do try that again. I go math.
It'll give you that every time.
Man, it seems like there ought to be a better way to do that. Is there not an easier way?
Is there a small button?
I don't think so. I think I gotta go there. So it's 5, it's the, okay. Yeah, I just gotta go up and put the, I gotta put the number in first. Can I go back and change that? Yeah, I can. You know, you can see this is kind of hokey. We don't even really, this way is not as good.
Oh, yeah.
I could put the 6 in there. What's that?
Not
Put,
4 weeks, dude. It just puts in a thing to the answer.
okay, and then you can just overwrite the 3 with something else if you want. So you can do it this way, but I wouldn't recommend it. I would recommend doing it using the fractional exponent. So I can put in the 6th root of 91. And if I hit enter, it gives me the decimal answer. But far easier to just say 91 caret, to the power of 1/6. Right? Way easier. Okay?
Way easier.
And if I want it, what happens if I try to put in negative 91 to the 1/6? Now you got to be careful with this though. How come this? Explain why the calculator is giving me this answer. If I put in negative 91 to the 1/6, it should say non-real answer or something, right? Should blow up. How come it didn't? What did I forget to do there that's important? Okay, remember, if I put a negative number, if I'm taking an even root of a negative number, I gotta put that negative number in parentheses if I do something with it. Otherwise, the calculator is only doing the 6th root to the 91 and then multiplying that answer by -1, which is not what I want, right? So I've got to go in parentheses, negative 91 to the 1/6, and now it tells me, oh, non-real answer, okay, right? As it should. There shouldn't be an answer. Okay.
Because it's too
Okay, so what if I want to do a fractional exponent, like let's say we do something like 91 to the 2/5. I mean, you just put it in like 2/5. It'll give you the answer. Okay? Same way we just did, but just make a fractional exponent. Way easier. Okay, so this gets us down to the most important part. This is the only part I really care about, and that is, why is this useful to us? Because now we can solve equations like we did in chapter 6 without having to use all this factoring stuff sometimes. We can just isolate x for powers other than just 2. For example, what if I've got something like this? 2 times x, the quantity x minus 1 to the 4th plus 10 equals 172. Okay, you actually probably could.
What?
You actually probably could do this in your head. Now, what would I do here? How many x's do I see in that equation?
1.
Now, what was our rule always in the past? If I can point to a single x, then I can isolate it, right? By just reversing order of operations. Same thing's going to apply here. If I go through the steps in this order, if I'm isolating x, what's the first thing I would do to both sides?
Parentheses.
Subtract 10. Okay, so step 1, subtract 10. So I get 2 times the quantity x minus 1 to the 4th equals 162. Excellent. Okay, now what? Okay, divide by 2.
Oh,
Okay.
yeah.
So if we divide both sides by 2, those go away, right? That's good. And we end up after the second step with just x minus 1 to the 4th equals 81.
Oh, I did that in my
Okay,
head.
now what?
Parentheses. Square root it.
Not parentheses yet. We got exponent,
It's a 4
right?
over the exponent.
And so how do I undo a 4th power?
Square root it twice.
No.
You square root them,
Undo a fourth power, you
I-
distribute it.
I do. Now think about this. Now use the same line of thought that you used if we were going to undo a square. We always square root it, right? So if we're going to undo a 4th power, we're going to 4th root. Make sense? Okay. So if we take a 4th root of both sides, then I'm going to get x minus 1 equals, now that's even though, right? Because that's even, if I do a 4th root, I have to put a plus or minus. Because I get 2 answers for an even, right? So I'm going to put plus or minus the 4th root of 81, which you already told me is just 3, isn't it? 4th root of 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's going to give me x minus 1 equals plus or minus 3, right? And then last step, yeah, if I go up to parentheses, the last step is I'm going to add 1 to both sides. And so finally, step 4 gives us x equals, I'm going to add the 1 in front of the plus or minus, right? 1
Plus or minus.
plus or minus
Tres.
3. So if I take the plus sign, what do I get? X equals 4. If I take the minus sign, x equals negative 2. Okay, let's do one with an odd. Just, I mean, not that they're any, they're actually easier. So let's do one with an odd real quick.
Bring it. They relate me to Jesus.
Okay, so what if we have, let's say, 2 times the quantity x plus 2 cubed. Oh gosh, minus
77.
82.
77.
82.
minus 1
Oh.
equals
61.
53.
5,860.
Okay? First step,
Plus one.
add 1. Now what?
Divide by 2.
Divide by 2.
That is. You know this one?
Cube
Oh.
root.
Cube root it.
Cube it.
Cube root it. Okay, now if I cube root it, do I need a plus or minus?
No.
Yes.
No, I don't. How come?
It's odd.
It's odd.
What?
If I take an odd root, I get 1 answer, right?
3.
Okay. Oops.
How does that make you feel? Like you proud of your mama?
1 answer,
Minus
3.
2.
Subtract 2,
1.
x equals 1. Okay, now would it have been a problem? Would it have been a problem if that would have been a, what if that had been instead negative, here, we'll just do it. Could we do this problem? Okay, I could divide by 3 and get x plus 7 to the 6th equals negative 100 thirds. Can I take an even root of a negative? No, I can't, right? Because this is even, and that is negative.
No answer.
No reals. Okay, yes, sir.
What if it was a negative?
What do you mean? If it was a negative, then it would have worked, right? Because then I would have had negative 100 divided by negative 3 is positive 100 thirds. Then it would have been fine, okay? But this one wasn't. Okay, is this okay? Okay, new problem. Is this okay?
Bring it.
90.
80, 80.
50.
Are you done?
Yes.
It's full.
Is that gonna be okay?
Yes.
We know right away, we're gonna get an answer, aren't we? Because that's odd. It doesn't matter if this is even. I can take the odd root of a negative. That's fine to do. So if I divide both sides by 2, I get x plus 5 cubed equals negative 27. What do I do? Yeah.
Could you take like 25, like negative square root?
Meaning, can I put a negative number in the radical? No, you can't. No.
Don't know.
It just doesn't mean anything. Doesn't mean anything to have like you could have a third root or a fourth root. Having a negative second root, it doesn't mean anything in math. Okay, good question. Good question. Now I could do this. I could say like 25 to the negative 1/2, because that's just 1 over 25 to the positive 1/2. Does that make sense? Okay, this is, see, if I have a negative exponent, our properties of exponents just tell us that's 1 over the positive exponent. Okay, so that's fine to do. Okay, but back to our problem here, then.
X plus 5 equals negative.
If I cube root both sides, x plus 5 equals the cube root of negative 27, which is what? No, negative 3.
Negative 3.
Okay, and then so I get, if I subtract 5 from both sides, x equals negative 8. One answer, done. Right? Okay, make sense? That's it. That's all of 7-1. And the big part of 7-1 is this stuff. To me, this is the most important stuff, is being able to use it to now, that's a great shortcut for solving equations. You know, some polynomial equations are easy to solve if we just isolate x, right?
Can we do that on the test?
No.
You know what? That's fine with me. That's fine with me. If you want to do that on the test, on the chapter 6 test, you can.
Wow,
That's
that's way easier than doing the other AG stuff.
Yeah, but there still are going to be some questions on the chapter 6 test that are, like when you want to do the procedural part, you got to say, you know, factor by difference of cubes, difference of squares, sum of cubes, stuff like that. Oh, and you're actually getting numerical answers, go ahead, that's fine. Is there time?
No, let's just sit here and chill.
You got 14 minutes.
You're 14 minutes. How's it make you feel?